Hello, everyone. It is my pleasure to welcome you to the 2025 year-end capstone presentation for the Water Engineering Technology Program. At this moment, I'd like everyone to reach into your pockets and please mute your cell phones. I'll begin first with acknowledging that our Kelowna campus is located on the traditional and unceded territory of the Syilx Okanagan people. I'd also like to welcome a few distinguished guests watching these presentations in the audience as well as live streaming. So members of the Syilx Okanagan Nation Alliance, representatives from the City of Kelowna, from the City of West Kelowna, Big White Utilities, the Associate Dean for Science, Tech and Health at OC, members from our Program Advisory Committee, representatives from the Water Association of BC, instructors at OC who have come to support and see our presentations, especially Allison O'Neill, Aaron Radomski, and David Teasdale, who spent many hours, often outside of lab times or on weekends, helping guide the students. Family and friends of the students as well as staff, and most importantly, of course, the students themselves. These capstone projects are the culmination of the students' learning over the past 2.5 years. These projects that they have undertaken highlight their academic experience by applying theoretical knowledge to real-world problems and are the proof that they had the skills, learning, and ability to go out into the world as professional water engineering technologists. We are naturally both very proud and pleased of their work that they have done and are excited to showcase their accomplishments with the capstone presentations. At this point, I would like to welcome to the stage our Associate Dean, Steve Kremoff, to say a few words.
Thank you. Good afternoon, everybody. I'm here to bring greetings from the Dean's office. I'm the Associate Dean. Unfortunately, our Dean, Alia Valadares, was called away from campus on a professional matter, but she wanted me to express our appreciation and of your dedication, the learning, the appreciation to the faculty, to all the special guests today. I have 3 sort of favorite days in a semester or an academic year. The very first day of school is exciting because you get to see all the fresh faces, the faces coming back after co-op, after a year of learning, after a summer off. You get re-invitalized by all the energy that's in the hallways and the classrooms, the labs, the schools, the common areas really come alive after a summer where it's a little bit lighter here on campus. The end of that semester is also convocation or graduation, which is another favorite day. You get to see the culmination of all that time, all that work. You get to see the loved ones, the family, the friends, the professional partners, all of the dignitaries that come and celebrate everybody as they walk across the stage, and we shake hands and we celebrate and we cheer and we sing, and that's amazing. And my third day, my favorite day, because I'm sort of an academic by history, is these days, is the capstone presentations. It's the culmination of that academic learning. It's the synergy or the synthesis of 2.5 years of learning across multiple courses, hours. Sometimes it feels like a marathon, perhaps, that you're now at the final line. And for me, the capstone presentations are really important because not just is it a culmination of all the learning you do here at OC, but it's the partnerships and the integration with the industry. It's the other people. It's the opportunity to present real-world problems, work with a partner, get real-world data, come up with something that can have a lasting impact for communities and for resources in our area. So between the start, the end, and the capstones, those are the 3 favorite parts of my job. So every time I get invited to these events, I always thank the faculty for the amazing work that you do, for the partners and visitors that are here to celebrate with us. That's amazing. And to you as students, I hope you recognize this as a capstone moment and you enjoy, although there is stress in a presentation, I hope you enjoy presenting to others the work you've done, the solutions you came up with, the innovative ideas that you have developed. So I wish you the best of luck in your presentations today. I'm very interested in watching a few before I have to leave for my next meeting. So before I pass the agenda back, we have a couple special guests here from the Water Supply Association of British Columbia, Chair Bob Rasco, and one of the directors, Patty Meir. Please join me in welcoming them to the stage. Thank you. You start? I'll start.
You start. Thank you. Good afternoon. Patty and I are really pleased to be here for your Capstone Day. We represent the Water Supply Association of BC. It is an organization mostly of water utilities that represents the interests of those water utilities in the front of the province and the public. It's been around a long time, since 1923. They had their original meetings here at the Post Hotel on Bernard between Water and right beside Water Street. And Post Hotel became the grand, it became the Royal Anne, and which since became there a long time. We have the original meeting minutes and the history of the place. The history, you know, I'd encourage you to, you're going to continue learning through your careers. It's never going to stop, especially in the water industry. Because Patty and I think we've been working probably 70 years of experience together, and I'm still learning new things every day, even this morning. I had people from UBC on the phone about the weather patterns. So we see the Water Engineering Technology Program as a foundational part of the water industry. You know, you're the up-and-coming young people that are here to develop and to grow and to serve. You know, what you learn is you end up serving the public. It's one of those core principles that drives an organization. If you have an organization that doesn't serve itself, doesn't serve each other, serves the public, that foundational piece will serve you well through your whole career. Patty has been the vice chair. She's a director with the association. She's been on the board now for 15 years. She goes on the plateau above Lake Country. I've been administrator for Black Mountain Irrigation District since 2004, and basically I've been the chair of the organization now for a little while, and I also sit on the Okanagan Basin Water Board. So you end up being in a position where you can influence the politicians in the region, mayors, and try to steer things into a direction where we're always protecting the water. It's like the air. It spreads through the whole fabric of the land and everything you do. So the water, what you're learning here, what Allison has done with the group here is fabulous. So we know a lot of people up and down the valley in the water industry. And what we're here to do is to present an award to somebody. And it's very hard to pick somebody because we know so many people. But we have an award for Allison O'Neill today. And if I could ask Allison to come up. I'm going to tell you some background on Allison that she probably hasn't told you. She has a Bachelor of Science degree in Civil Engineering. She's a professional engineer. She has a Master's of Education degree in Leadership and Administration from Gonzaga University, and she's taught a wide range of applied courses, including hydrology, well, you know all the courses, hydrology, hydrogeology, municipal water distribution, surveying, environmental law. She is a longtime member of the Water Stewardship Council, probably there since the first days in 2006. When I was there, Patty was there. And that group has grown through the years to be a very, very smart bunch of people on water. She's a longtime member. She's also recently elected to the Environmental Application Program, EOCP, and she serves as their treasurer. So she, away from Okanagan College, she spends a lot of time still serving the water industry in varying ways. She has a very close working relationship with our industry, and she has no hesitation in calling any one of the managers for a tour of whatever facility she thinks the students need. She's been at our UV site. She's been, I think, at our water treatment plant lots of times. If she needs a presentation on things like, you know, lake intakes or UV disinfection or water treatment or even water tunnels, she manages to scrape that up through the industry and the hard work. And for 2 decades now, she has this program, which is an industry-connected program, probably the best in the province, I would say, from all I know, because it's very difficult to try to match up the technical stuff that goes on in a college or a university with industry. It's always a challenge. There's always new things being developed, but she does a great job at that. She's been instrumental in developing the tech program and gives the students the hands-on skills they're going to need in their careers. So She's also worked, I think, 12 years as a consultant. And I remember, I think it was 2005 or 2006, she phoned me up and says, I need a job, a summer job. And she wanted to work as an operator at Black Mountain Irrigation District. And and it was so that she could be a better teacher for her students. And, you know, how could you say no to that, right? So, yeah, she worked with us for the summer. I hope she had a good time. She had a great time. And she also, from the Water Supply Association, she set up with us the Scholarship Award Program. We give out money every year to a deserving student, and there's always many of them. And you know, she is someone who deeply cares about the water valley and has done more than her share to protect and manage. She does that through the students. You know, so I can say that from the Water Supply Association, we're very pleased to present Allison with this Distinguished Service Award for 2025. So, thank you so much. And we want a picture with, if they can turn the lights on in the crowd, we would love a picture with us and her and the students here.
Yeah.
Can you do that? Here's somebody.
Can one of you take a picture? Oh.
You got to push a button here. That's yeah. Okay. So here we go. Just if we can just stand it like this, and you can take it with the group.
Okay.
Here, David.
Dave, can you take the picture?
Don't cut our heads off.
Squeeze in, students, just
Yeah.
to get in the shot.
Okay.
No idea.
You guys
Ah.
Ready?
take a couple. Yeah.
1, 2, 3.
Okay.
Okay. 1,
Yeah.
2, 3.
I got 4 or 5.
Perfect. Thank you so much.
Very good.
I'm going to take one more because I didn't get them all. 1, 2, 3.
Thank you, guys.
Thank you.
I also have a book here for Allison. There's a 100-year history of the Black Mountain Irrigation book, district book. It's called Black Mountain Gold. Judy Steves wrote it 3-4 years ago. And I have 2 more books for somebody in the audience, whoever answers. What's the largest creek in the Okanagan supplying Mission Lake? Or sorry, supplying Okanagan Lake. Geez, I screwed up. Come on, somebody speak up. Mission Creek here? Which one? That was the easy question because I gave it away. Okay, second one. What's the second largest creek supplying? Yeah, there we go. Another book right there. Thank you. So, anyways, thank you so much.
Thank you.
Okay.
Son is surprised.
You need that?
We don't want these lights on. Perfect. Alrighty, now on to the presentations. So Group 1 presentation is a feasibility study of lab-scale microbubbler diffuser for surface water treatment. The group members are Ryan Grimm, Shane McCune, and Adrian Ronald T., who've just left the building. Yay, there they are. Woo. All right. This project evaluated the feasibility of using the Nikuni pump and the effectiveness of microbubble flotation in removing contaminants from the water by building a laboratory-scale microbubbler diffuser and testing it in a controlled environment. And there will be lots of time for questions after the presentation. All right, gentlemen? Oh, I do have one request from our IT wizard who's running things in the back, Jamie. Please try not to sit in front of the cameras, and when you are speaking, hold the mic closer to your mouth, please. Right.
Give me 1 sec. Okay. So, good day, everyone. On behalf of the students for the Capstone presentation, we would like to thank everyone for coming here today. And we are excited to present our Capstone projects. So for our group, our Capstone project is feasibility study of lab-scale microbubble diffuser for surface water treatment. On behalf of our team, we would like to extend our thanks to the Water Engineering Technology Department for their overwhelming support and commitment towards this project. The Okanagan College Technologies Division for their dedication to learning and innovation that drove this project into fruition. We also would like to thank our Capstone project instructor, David Teasdale, for his guidance and expertise throughout this project's duration, and our lab technicians, Roland, Gabriel, and Matt, for their advice and aid in materials acquisition. And of course, to our instructors, whose advice and experience help us execute this project. Before we begin our presentation, I would like to introduce our team, Clearwater Initiatives. Please welcome our team, the tall one, Ryan Grimm, the military man, Shane McCune, the loud one, and our rockstar of an instructor, David Teasdale. Our collaborative efforts allowed us to execute and complete this project. Microbubble flotation is an advanced water treatment technique that utilizes tiny bubbles to efficiently separate suspended unwanted materials from our water resources. These tiny bubbles carry the contaminants to the surface where it forms a froth that can easily be skimmed off. As for the scope of this project was initially intended to be used for algae flotation in surface water such as lakes and ponds. However, due to the strict time constraint of this project, it was decided to best focus on developing and designing a modular lab-scale microbubble diffuser. To talk about the modifications and additional changes we've made in this project, please welcome the tall one, Ryan Graham.
Thank you very much. My name is Ryan Grimm. I'm obviously the tall one, and I'm here to talk about the modifications that have been done to our project. To start things off, we can talk about the acrylic tank. Upon initial inspection of the previous tank that was left for us on the left image there, the tank was quite run down. With that, the sides were dirty with residue from previous usages from previous groups. Side panels were cracked and incredibly scratched, which happened to dampen the ability to, obviously see through. With the poor visibility and, the scratches and cracks along the sides, the original plan was to use the old tank, but with the plates being fused inside and, risking structural integrity, it was decided that we needed a new tank if we ever wanted to test our later designs for our diffuser. The new tank, which is on the right side, was designed and ordered from Alcaro Plastics. It was designed to retain a 16-inch fluid level with the inlet and drain valve fully opened. To ensure that this criteria was met, Torricelli's equation is used to determine the size of the out hole, or the output hole. After calculations, it was determined that the hole would need to be at least 1.44 inches in diameter. However, commercially available stuff determined that 1.5-inch bulkhead fittings will do the job just well. Another issue was the thin walls that the new acrylic tank had. With it only being 6 millimeters, we were worried that the structure could potentially bulge or burst. Therefore, a wooden grooved brace was crafted and fitted to the top of the walls to enhance the strength to the structure while maintaining adequate access to the diffuser to fit through. Next up, the vacuum gauge. Based on observations while being noted by the previous group, the original vacuum gauge that we had did not zero. With accuracy put into question, we decided it was best to replace the old vacuum gauge with a more newer vacuum gauge. This ensures that accuracy with the vacuum conditions within the was, true. Another issue was water leaving the vacuum line. Upon further inspection, it was determined that the inline check valve for the vacuum line was clogged with dirt and other debris, and upon cleaning the check valve and reinstalling it back, there was no longer any water leakage. In the previous setup, the discharge piping to the Nikuni pump also required replumbing. The old T configuration was restrictive, with multiple valves and bushings that reduced the pipe diameter from a ½ inch to a ¼ inch in certain sections. These restrictions caused pressure drops, which allowed air bubbles to come out of solution prematurely within the discharge tubing before reaching the diffuser. Ideally, bubbles should remain saturated in the water and only come out of solution at the diffuser's nozzles, where bubble formation is maximized. To address this, the separation column was replaced, which is in the left image there, with a dedicated hose line that connects to the discharge side of the Nikuni pump directly into the diffuser's common header, which is on the right. The modification reduces head losses by eliminating the restrictive fittings of the separation column. With proper needle valve adjustments of the inlet air in the discharge line free of restrictions, the air remains dissolved throughout the piping until it reaches the diffuser. Additionally, a mesh filter was installed on the inlet pipe to ensure debris-free water supply. This helps the pump and prevents clogging of the diffuser nozzles, ensuring reliable operation and consistent bubble formation. To add on to that, the recirculation tank had to be capped and reconnected to the recirculation pump to be able to supply our DAF tank with water. And now, to talk about the diffuser design, the military man himself, Shane McCoon.
Thank you, Ren. So we should be about the 5-minute mark from in that tank, so you can see most of it is already kind of lifted up, so that we'll let the bubbles do the work and we'll check back later. So I'll talk about the diffuser design first. This is our final iteration here. We have tapped PVC T's for quick nozzle swaps and reconfiguration. We have a gear clamp header on the one side, which allows us to change things easily. If we had glued everything, it would have been impossible. The runners are threaded as well to make it easier. We used a mix of misting nozzles to balance the fine bubble generation with pressure flow and tuning. So it's easy to test new nozzle type sizes and arrangements. It's an adaptable layout. It's an adaptable layout using a forerunner design which distributes flow scalable to different tank sizes or geometries and supports trial and error testing without major rebuilds. So future potential framework. It's a framework that encourages other groups to apply their own ideas, and the outcome was optimized bubble size distribution and efficiency tailored to specific project goals. So here you can see the two different nozzles that were used. The smaller misting nozzles actually clogged quite easily, did not provide enough flow without the internals removed from them. As you can see, the parts that we removed from there, and then just ran the nozzle body full. So these are the results from our first tank startup here. Here you can see the flotation tank at startup with confetti and glitter contaminants mixed throughout the tank. For our results and conclusions, performance outcome, current diffuser design provided good dispersion of microbubbles throughout the tank. Glitter and confetti mixed until fully suspended, simulated algae and microplastics. The pump was run for 5 minutes. The bubble cloud formed, most debris afloat by the 5-minute mark. By 10 minutes, The bubble cloud had reached the surface, the tank was clear, and the majority of the debris removed. A small amount of glitter remained at the bottom and some confetti strands that were stuck to the nozzles. Pump operating conditions, the vacuum measured at negative 10 inches of mercury with a discharge pressure measuring at 45. We were trying to hit 60 to 80 psi. It was kind of a constant push-pull battle between the vacuum and the pressure. As the pump had been discontinued, no engineering data was available for it. So key takeaways, the diffuser design proved effective, qualitatively encouraging results for debris recovery, and the system may require a pump with a greater pressure head and flow capacity. So here we can see the microbubbles forming and the particles just starting to agglomerate. And here we can see a trial approximately 5 minutes into the trial. The pump has been shut off and the majority of the debris at the surface, and the microbubbles will rise and lift the rest. So here we have results after a 10-minute trial. It was from an earlier test, which only had 2 runners. Debris clumped together at the water's surface, and bubbles could be seen under the debris mats, providing buoyancy in the picture there on the right-hand side. So our recommendations for future improvements for the pump and tank setup, we could reconfigure and place an Nikuni pump above the DAF tank to reduce discharge head elevation, increase pressure to the diffuser. The diffuser design, we could increase pipe size to lower friction losses and raise the dynamic pressure. Extend the runner pipe length a bit longer to cover more of the tank and disperse bubbles a little bit more uniformly. And then compare different nozzle sizes, refine the diffuser layout for operational requirements. A pump upgrade, like I said earlier, the Nikuni KTM15 has been discontinued. So the next biggest one up is the KTM20 now. And it's about twice the power. And there's actually engineering data available for it. Feed line adjustment, we could increase the inlet pipe diameter to minimize suction losses. We might want to relocate to the larger bulkhead fitting off the side, but it would make it quite a bit wider than the frame, which is an issue moving it in and out of doorways. Quantitative testing to actually determine the contaminant recovery efficiency. Thank you all very much for being here. And I'd like to open the floor for questions. We did use the different nozzle heads. The larger brass ones, you can see.
Can you repeat the question?
I'm sorry, what, the question?
Yeah, just repeat the question.
Okay, so did we test different bubble sizes? Was the question? Yes. So we did use the 2 different nozzle sizes. The brass ones do tend to make a bit larger bubble, which we didn't want, but they were useful in giving us some more adjustment. They had a longer thread length on them. The smaller misting nozzles were better at producing the fine bubbles when they had all the guts removed. Actually, the best result was when everything was hooked up. We would unscrew them at just at the point of popping them off, it was actually the best cloud we could see, but obviously that wasn't sustainable with someone holding their hand there the whole time. So yeah, we tried to, but yeah, just with those nozzles.
To answer that question, the question was like, if we were to integrate this in the system, how are we going to integrate it, right? So the initial plan for this project was for the diffuser to be used in lakes and ponds. So basically, you're going to carry it. That's why we have a modular design with the Nikuni pump, and then you have a generator that's like small enough to fit in a boat, and then you're gonna like ride on the boat with the diffuser, drop it to your desired elevation, and then pump it up, and then a skimmer would follow through to skim all of the algae that was like being removed by the diffuser. That was the initial scope, but like because of the, as mentioned, strict time constraint of this project, we didn't have any initial plans for the diffuser. We didn't have any like background study on it, so we had to like basically start from scratch, and like basically we just tried to focus on making a diffuser that would like float all those algae and like that could be scalable in the near future. So yeah. Okay. Mhm. Yeah. So to repeat the question, they were asking on like how or like what's the advantages and disadvantages of using it in a real world setting. So first of all, the disadvantage is like power, because it's hard to put a generator in a boat that's enough to power the pump on like, I don't know, like 4 hours or 8 hours if you want to, like depending on your runtime. And the next one would be it's hard to target like the actual elevation that you want, right? Because algae, as we know, is either floating or it's suspended. And without a river, like a profile for it, you can't like actually, what do you call it, specify or like actually pinpoint the location that you want to remove it. As for the advantages, it would be a good pre-treatment, especially if you have like the intent was like to use it in the reservoir in Rose Valley, and so they have like algae problems like on their down like on the reservoir, right? So if we can float that, that would mean that they don't need to do as much treatment on the downstream side. So like that's one of the applications of this technology. Are there any questions? Okay, thank you.
All right, thank you guys. Now for the second presentation of the day, we have optimizing oxidation with ORP. Group members are Angelica Calub, Jeremy Mann, Nathan Light, and Tyson Harrington. Welcome. Oh, I'll give you a quick, do you guys want me to get the background very quickly? Okay, sorry. This Capstone project focuses on optimizing dissolved metal removal in West Kelowna's Rose Valley Reservoir drinking water system by developing a real-time potassium permanganate dosing strategy, monitoring the oxidation reduction potential, ORP, in millivolts, and correlating the measured value to an efficient oxidation state of dissolved metals. The goal of this project is to reduce chemical costs and provide a SCADA monitored value that can indicate changes in water quality to the treatment operators. Okay, I've done my job, now it's your turn. Okay.
So, good afternoon, everyone. We are here to present our Capstone project titled Utilizing ORP Measurements as a Strategy for Manganese Oxidation. Our group is called the Triple O, which stands for Optimizing Oxidation with ORP. And I want you to meet our team. Angelica, Nathan, Jeremy, Tyson, and our project supervisor, David Tisdale. So here's a quick here's a quick roadmap of what we'll be covering for today. We'll start with an introduction, then we'll provide a brief overview of ORP and its relevance to this project. After that, we'll go through our methodology, followed by results and data analysis and the challenges we encountered during testing, and finally, our conclusions and recommendations. The Rose Valley Water Treatment Plant receives its source water from the Rose Valley Reservoir. Located in West Kelowna, this reservoir supplies drinking water to more than 20,000 users, and all raw water for the plant enters through the intake structure at the dam. After the plant began operating in May 2024, operators experienced issue with dissolved manganese in the raw water. While solid manganese is typically removed by filtration, dissolved manganese can pass through the treatment process and later oxidize in the treatment water reservoir. And this can lead to color issues, staining, taste, and odor complaints. To address this, the city installed a permanganate pre-oxidation system at the intake. While the system is effective, dissolved manganese levels fluctuate throughout the summer, making it challenging to maintain the correct dose. Our project aims to determine whether ORP can be used as a real-time control tool to help operators adjust the permanent dose more accurately. I'll now hand it over to Nathan for the ORP overview.
Thank you. So what is ORP? ORP stands for Oxidation Reduction Potential, which measures the water's ability to accept or donate electrons to reduce or oxidize certain species displayed in a millivolt reading. At less than 200 millivolts, manganese is seen to be present in the dissolved 2+ form. From 300 to 400 millivolts, manganese forms are seen in a transitionary stage with dissolved manganese 2+ and solid manganese dioxide. At 500 millivolts, all manganese should be seen to be solid manganese dioxide. ORP can aid in guiding the pre-oxidant dose to an ORP level where oxidation is known to occur in the water. This level can be beneficial as to not overdose or underdose permanganate as water parameters change throughout the year. I'll now hand it over to Jeremy to discuss methodology.
Thank you, sir. Hello, everyone. Thanks for coming out. Our project began by meeting with our industry partners at the City of West Kelowna. We collected historical data, including layered aquatic reports, in-house lab results, reservoir quality data, and Caro analytical results. This gave us important background information on qualities like dissolved pH, temperature, and metal concentrations. The next step was for us to acquire our own data, so we hit the open water. With the help of our friend Captain Wittich, we were able to record an ORP depth profile, recording data from the surface to the lake bottom at a location near the treatment plant intake. Then we collected raw water from the dam, from the sample line to use for our project. The main objective of the experiment was to create an oxidation dosing curve based on the change in ORP values as we added specific amounts of potassium permanganate. In order to achieve this, we had to create a permanganate solution. This was made by dissolving 0.1003 grams of potassium permanganate into 1 liter of DI water, making a 100.3 milligram per liter solution. For each increase in dose, data was recorded for the change in ORP, pH, and temperature. The stock solution was then added to the Rose Valley sample water in increasing doses from 0.2 milligrams per liter to 3 milligrams per liter. This first experiment was successful, but we had a problem. At the time of our sampling, we had missed the peak window of manganese content in the reservoir. In order for us to confirm that an ORP-based dosing strategy would work, we needed to run a trial with more dissolved metals. To achieve this, we experimented with further trials mixing in liquid manganese sulfate and liquid iron sulfate heptahydrate to the Rose Valley sample water. By adding in additional dissolved metals, we were able to create another dosing curve with a water with dissolved metal concentration of 0.33 milligrams per liter, which is around 3 times the maximum allowable concentration. To confirm that our dosing curves were effectively oxidizing the dissolved metals, 3 samples were sent to Caro Analytical Services to compare a control sample, the current oxidant dose at the time of our sampling, and our recommended ORP dose. I'll now hand the stage back to Nathan to discuss the results.
Thank you, Jeremy. So the graph on the left displays our permanganate testing with live ORP reading on our raw Rose Valley sample water. Our graph on the right displays the same testing done with spiked Rose Valley raw water. The goal of these tests was to highlight the requirement for more permanganate as metals concentration was increased. Both graphs are seen to hit their breakpoint and then taper off, showing that the water's matrix has switched from a tendency to reduce incoming species and rather oxidize them. The success of these tests are seen with the amount of permanganate required to hit the 450 millivolt ORP mark. This mark was seen to require approximately 1.1 milligrams per liter of permanganate in the spiked sample, compared to the approximate 0.9 milligrams per liter in the raw water. This confirms that dissolved metals decrease ORP, leading to an increase in demand of permanganate to satisfy the 450 millivolt mark. This bar chart represents iron and manganese concentrations in 3 samples analyzed by Caro Analytical Services. The control sample is used as a baseline to evaluate how effective the ORP dose and operational dose fared for removal of iron and manganese. The initial values for the control sample were 0.08 milligrams per liter of manganese and 0.1 milligrams per liter of iron. The ORP sample was dosed with permanganate until an ORP value of 450 millivolts was achieved. The current sample was dosed at a permanganate value of 1.3 milligrams per liter, mimicking Rose Valley Water Treatment Plant's dose. Both the ORP dose and operational doses saw a very clear reduction in manganese 2+ and iron 2+, with the ORP dose performing nearly as well as the operational dose, with a concentration well below the maximum allowable concentration of 0.12 milligrams per liter. Moreover, the ORP dose was able to use approximately 25% less chemical than the current operational dose. If ORP were to be implemented, this 25% decrease in chemical usage would be a large benefit to the Rose Valley Water Treatment Plant from an economic standpoint. I'll now hand it over to Tyson to discuss experimental challenges.
Thank you, Nathan. Hello, everyone. I'm Tyson Harrington, and I'll start by briefly firing through the main experimental challenges we encountered, followed by some future recommendations by our group. So the first major issue was sample oxidation and transport. During one of the initial visits to Rose Valley, our raw reservoir samples were exposed to oxygen during handling and storage, which caused dissolved manganese to oxidize and precipitate out of solution before we had a proper chance to test them. Once that happened, the samples no longer reflected true raw water conditions, limiting their usefulness for ORP testing. Another challenge was the use of deionized water. After using DI, the group noticed stable and unrealistic ORP values. Without dissolved metals, alkalinity, or buffering capacity, the ORP readings fluctuated sharply and did not represent what would realistically occur in reservoir water body or treatment systems. Altogether, ORP measurements were highly sensitive to operational factors. Sample handling, probe calibration, temperature changes, and surrounding environmental conditions all influence the readings. This highlighted how delicate ORP measurements are and how easily they can be affected and distorted if conditions are not tightly controlled and monitored. Now moving on to our recommendations. Based on these challenges, we have a few to share with you. So first, based on our lab testing results and the CARO analytical data, we recommend moving towards ORP-based real-time monitoring of permanganate dosing. In our testing, manganese iron oxidation consistently occurred once ORP reached roughly 450 millivolts. We also recommend placing ORP probes at both the raw water intake and after oxidization, as this would give operators an early warning of increased dissolved metals, chemical delivery issues, or overdosing before problems show up as color, turbidity, or customer complaints. And to wrap things up, this project showed that oxidation reduction potential is a practical and effective tool for managing dosing erosion treatment plant. The lab testing and CARO results demonstrated that the sodium permanganate dose could be reduced by roughly 25% while still achieving effective oxidation of dissolved manganese. This highlights a clear opportunity for improved chemical efficiency and cost savings. Overall, our findings support ORP-based control as a simple, effective way to optimize permanganate dosing, reduce chemical use, and improve operational awareness. This approach offers real value to operators and presents a practical improvement to existing treatment practices at Rose Valley. And last but not least, I want to give a special thanks to all of our industry partners, our college professors for their assistance and support through everything, and most importantly, Felix, our emotional support cat. Thank you. Yes.
I noticed that you had put the two instruments before and after, and those were actual pictures. No, from the intakes, like.
Those are actual pictures from the site at the dam intake and in their raw water analyzer board, yes,
Yeah.
but those are made by Angelica.
Yeah.
Those are not a real thing.
Yeah, I kind of got that, but how easy do you think it would be to put these on there, like to integrate it?
They are already using live sample water-fed analyzers at both locations, so it shouldn't be too impractical.
Hello. Can you hear me? No, I just wanted to know, so you have a 25% reduction in usage of chemical based off of using the ORP. What are they using right now to decide? Is it just guessing, or?
Sure.
At the moment, I believe, well, in the summertime, they were sending lots of samples to CARO and doing jar testing to kind of figure out how much they were removing with what dose, and then with the CARO samples, they were able to kind of see what their best dose was for removal of manganese. So it was kind of just in the summer during peak concentrations, it was like just weekly jar tests.
And they do also have some online dissolved manganese analyzers by ABB. They have seemed to have a little bit of issues with them, though, so this is kind of supporting technology that I think could make a difference.
All right, for the third presentation, this is for Big White Powder Basin Drinking Water System Design. And the group members are Abram Larson King, Anna Paez Alape, thank you, Jenny Griffin, and Marcus Stewart. This Capstone project evaluated and assessed the feasibility and cost of the implementation of different treatment options for Big White's Powder Basin drinking water system. The treatment options were designed according to key water quality parameters, such as organic matter and turbidity, in order to meet the drinking water regulations and objectives to reduce the risk for public health. And that.
Thank you, Frank. Hello, everyone. Thank you for being here today. I would like to introduce our Capstone team, the Big Aqua Avengers. I'm Jenny Griffin. I will be sharing Big White's background and the scope of our project. Abram Larson King will explain the regulatory framework, limitations, and data review. Marcus Stewart will discuss the feasible technologies and the treatment system designs. And Anna Maria will review the costs for each system and make recommendations. Today we present water treatment solutions for Big White Ski Resort, specifically focusing on the Powder Basin Water Treatment Plant. The goal is to upgrade the plant to comply with regulatory standards, ensure redundancy across the resort, design a sustainable treatment system for future growth, and do so cost effectively and with manageable complexity to allow operators to run it efficiently. Big White Ski Resort is one of Canada's premier mountain destinations, receiving local, national, and international awards for its terrain, amenities, and visitor experiences. The resort is located 55 kilometers southeast of Kelowna in the Okanagan Valley, within the traditional and unceded territory of the Silks people. Since opening in 1963, Big White has grown, evolving from a small ski hill into a world-renowned family ski resort. Today, it is the second largest mountain resort village in British Columbia and continues to grow in infrastructure, amenities, and annual visitation. The resort's long-term master plan outlines future developments, including more biking and hiking trails, a mountain coaster, an aerial adventure park, and zip lines. These new developments are expected to reduce seasonal variations and further elevate Big White as a four-season destination. Reliable, high-quality drinking water is a necessity that directly affects public health, commercial operations, and visitor satisfaction. Currently, Big White Water Utility is privately owned and operates two separate water treatment facilities, each with its own reservoir. Ronda Lake Reservoir is located at a higher altitude with a catchment area made up of rocky terrain and sparse vegetation, resulting in high quality water with low organic content, hardness, turbidity, and pH. As a result, the Ronda Lake facility qualifies for a filtration exemption. Ronda Lake Water Treatment Plant was the original treatment facility and continues to supply most of the resort's treated water. Powder Basin Reservoir is located at a lower elevation. It has a larger catchment area composed of coniferous trees and vegetation, leading to lower water quality compared to Ronda Lake Reservoir, with higher organic content and turbidity, especially during seasonal runoff. Unlike Ronda Lake, Powder Basin does not qualify for filtration exemption. Therefore, the current UV and chlorine disinfection system is inadequate and must be upgraded to meet Interior Health's 43210 drinking water objectives. And I'll pass it to Abram.
Okay, so the regulatory framework. Big White drinking water is regulated under the guidelines for Canadian drinking water quality. In British Columbia, guidelines are enforced through Drinking Water Protection Act and regulation with oversight by Interior Health. Interior Health applies the 43210 drinking water objectives, which is 4 log virus inactivation, 3 log Giardia and Cryptosporidium removal / inactivation, 2 treatment barriers for surface water sources, less than 1 NTU of turbidity, and 0 detectable E. coli or fecal coliforms. And so Big White currently has a filter exemption for their Ronda Lake water supply. This is because they meet the criteria in the 43210 of 0 E. coli, less than 1 NTU. It's very stable. This has been applied by a drinking water officer, which could not be attained for their Powder Basin water source, as it had E. coli and higher levels of color and turbidity, which is not going to get you that exemption. And then so key limitations for Big White are that it is a rural community. There are currently 300 permanent residents, but it goes up to 16,000 visitors during peak ski season. It is a high elevation resort, which puts poor road or inaccessible roads into the equation during the winter. There can be delayed deliveries of chemicals and parts and increased transportation and operating costs. There are also financial constraints. Big White operates as a private utility, not eligible, or it's usually not eligible for government infrastructure funding. They must balance the regulatory compliance with reasonable water rates for strata members up at Big White, so they don't have a large amount of cash to play with. Our systems are in between approximately $170 and $6 million for Big White. And so another limitation is cold temperatures. The village is at 1,700 meters, and obviously winter conditions, like you see here on the picture on the left. The lakes are frozen. It has extremely low water temperatures, which reduces the chlorine effectiveness, slower coagulation, reduced sediment settling times. There's also a lot of snowfall up there, obviously. This has access issues. Usually the Powder Basin area in the winter is only accessible via snowmobile, which makes major maintenance limited to the shoulder season or the summer. And then there's also a variable water demand, which with the 300 permanent residents and 16,000 peak residents during the winter, you can see very stagnant water in the lower times. And also another constraint is the size of the system. They don't have the size to do coagulation or flocculation in large-scale settling tanks, so we have designed systems that will fit in the Powder Basin plant, which is approximately 9 by 14 by 3 meters in size. And then for the data review, as you can see here, the true color is quite high at some points, and it can go in between 18 and 25 TCU, which indicates elevated natural organic matter. This risks the formation of THMs, which are trihalomethanes in the water. These can cause health effects, they can potentially cause cancer, and there are regulatory concerns for them. And then so there's also a very low pH, which once we use coagulation chemicals as well would drop even lower, which increases the potential for corrosion and damage to the distribution system over time. And so we are going to require pH buffering for our systems, which will either be calcite contactors or chemical alkalinity addition. And now I will be passing this over to Marcus, and he'll be covering feasible technologies and the 3 systems which we've designed.
All right, so chosen guided by these limitations and the water quality of Powder Basin. These feasible technologies include multimedia pressure filters, as shown on the left, which can house media like Nextan, granular activated carbon, and calcite, and media like that. Nextan is a filtration media that's good at removing finer particles and can be used in conjunction with coagulation. Granular activated carbon is a filtration media that is good at removing organics and improving taste and odor through adsorption. Calcite is a filtration media that uses crushed limestone and can neutralize corrosive water and increase pH, which can improve the lifespan of Big White's distribution system by reducing corrosion. Cartridge filters are tube-like filters with small pore sizes, as shown on the middle image. They are able to remove particles smaller than human hair using membranes. They count towards filtration, unlike pressure filters, assuming that they have an absolute pore size of 1 micrometer. Sorry. And they also require a much smaller footprint than typical filtration. Nanofiltration is similar to cartridge filters, but with significantly smaller pore sizes, 0.01 micron to 0.001 micron, meaning it is able to remove much smaller particulate, including organics and color. Nanofilters have spiral-bound membranes with cross-flow filtration, and due to their tiny pore sizes, they are very prone to clogging without a proper pre-filtration system. Typical water treatment facilities use conventional systems with coagulation and flocculation. They typically require a large footprint but are highly efficient and widely used. This sort of system can be partially achieved in a small footprint using inline coagulation with static mixers and pipe flocculators, as seen on the images on the right. Static mixers can mix the coagulant after injection within the piping, and pipe flocculators can allow for the flocks to combine and do what flocculation tanks do, but in a much smaller space. So with these technologies in mind, 3 different systems were designed. System 1 was designed with this inline coagulation and flocculation at the forefront, and it is our most complex system of the 3. Caustic is injected prior to coagulation, as coagulant can drop the pH of water. Coagulant is then injected, and flocculation occurs within a pipe flocculator before entering our Nextan pressure filters, which removes much of the particles and now combined floc. After the Nextan filters, granular activated carbon pressure filters are used to reduce organics that aren't removed in the Nextan pressure filters. After that, cartridge filters are used to comply with regulations, and water is then disinfected by UV and chlorination. Our second system uses nanofiltration. Due to how small nanofilter pores are, as mentioned before, pre-filters are highly recommended. In our design, we have cartridge filters, but bag and sock filters are also recommended to use prior to increase the lifespan of the nanofilters. And afterwards, calcite pressure filters are used to neutralize the pH prior to disinfection. System 3 is our simplest and cheapest option. It is also our only option with no chemical usage prior to the pre-existing chlorination, as nanofiltration does require some use of cleaning chemicals to improve its lifespan. System 3 only uses cartridge filters, granular activated carbon pressure filters, and calcite pressure. Similar to System 2, sock or bag filters are recommended before the cartridge filters to improve their lifespan. Granular activated carbon filters are used to remove organics, and calcite filters are used to improve pH, and then the water is disinfected using the existing equipment. And now Anna will compare these systems.
Thank you. Good afternoon, everybody. My name is Anna. You might be wondering how we design those systems, basically how we choose the different technologies. So basically we designed criteria based on those factors that are qualitative factors that we give like a range, like a qualification to make a score. And basically from that score to get which will be the most feasible technology or system to be applied for an upgrade for Big White. The first factor is the space footprint, basically the environmental impact or the environmental pressure will exert on the land. Conventional treatment systems will require more space compared with advanced technologies like membrane filtration system. Infrastructure is basically the coverage, the housing for the equipment and the space enough to guarantee maintenance for that equipment. The equipment, some technologies are more complicated or require more features. For example, conventional filtration systems based on coagulation, flocculation, and clarification will require more equipment like rotors, motors, tanks, chemical usage. This is based on all the substance that we'll need to add it for the treatment process. Basically, what we need to guarantee to remove all the material organic. That is our purpose on this project. The training. The drinking system facilities at Big Y currently has a level 2 of certification with the EOCP. If we want to upgrade to different facilities or for each one of these new systems, we need to consider that the certification of the facility and the certification of the operators that they will need for operate these systems should be upgraded too. So that was another topic used for assessment. Sludge management. This is so critical since some of the treatment systems require or will produce big loads of sludge that should be considered to be removed and disposed correctly. That increase a lot, everything related with space, infrastructure, equipment, chemical uses, and also training. So this is the end of our grading score, and we can see the 3 different systems that Marcus showed to us, and an abbreviation of each one of the factors that we use to rate them. So the system 1, even that is an inline coagulation and a flocculation system that is a smaller size compared with a normal flocculation and coagulation systems, they are still having a big rate because they require more space compared with a cartridge filter, compared with a gag filter. They will require also more training. It's a more complicated steps. Infrastructure equipment and cost effective too is, well, I'm going to show you the cost of all the systems, but this is the most expensive too. And it seems that our system 3, how Marcus said, is our feasible option. Okay, well, I may say that courtesy of Bipure operating and design company, we got an estimated cost, like a general cost of the different technologies. What we did was basically to use the price of the Nexan, the coagulation, the flocculation system, add them all, and get like an estimated price for the system, including chemical cost, power consumption, and average replacement of any of the parts. And you can see that the system 1 is still really, really pricey on the system 3. The funny part is what is expensive is not the coagulation or the flocculation system, it's the Nexan. So I may say that conventional treatment systems are decided by the cost effective, the design compared with the others. So in our conclusion, the feasible treatment system that we can recommend for Big Y Ski Resort to upgrade their Powder Lake drinking water facility will be our system 3 based on cartridge filters, compound by cartridge filters, GAC filters, calcite filters, and it will be added to the current system that is consisting in UV filtration, UV disinfection, and chlorination injection. Our recommendation, well, this is like a surface review over what can be added for an upgrade. But it's important that the selection of a treatment designs must consider source water quality, impurity type, and cost, and based on historical data. Analysis of water quality parameters to ensure the treatment technology is appropriate, but it's important to consider like pilot scale testing for a design, and then maybe evaluate the considerations and further considerations that we can see in the variations of the raw water. And we have different partnerships, and one of them that is Napier Reed, an engineering consultant company. Basically, they proposed us, according to the water quality parameters, that the best option will be a conventional treatment process, followed by granulated activated carbon, like GAC, and basically this is for removing all the organic material. And well, consider the option of the other sources of water will be important too. I mean, it's important to spread for more options in the case that we cannot get water from our stream waters available. So one option is to get water from groundwater sources, and improving our strategies to protection of the watershed. Okay, this is an acknowledge of all of our partnerships that we just want to say thank you. By Pure Water, Big Y Sky Resort, our customer, Napier Reed, the EOCP Environmental Operator Certification Program, the Aqua Consulting, Environmental Energy, and Carolo Engineering. Thanks to them, this was possible.
Slowed it down. That was really good.
Any questions?
Hello. What was the, do you know what the estimated cost would be for the Napier Reed?
That one was around, well, we were given by them around 6 million for installation. Oh, not including installation for all the components and whatnot.
Why did System 2 have so much power requirements, more so than the other two systems?
It requires a lot more pressure at the intake for the nanofiltration, so it's a lot more power usage for like pumps and whatnot.
Thank you.
All right, thank you guys. We're going to take a quick 15-minute break, so we'll be back exactly in 15 minutes. right, welcome back from the break. Presenting now is Group 4, and they are doing the Shingle Creek Watershed Monitoring Project. So the group members are Priscilla Law, Shiny Tamel, Stefan Pollack, and Tom Wilbrink, sorry. The Silic Okanagan Nation Alliance is the inaugural First Nations government in the Okanagan, which represents 8 member communities. The Penticton Indian Band is one of these communities. The water engineering technology students work together with the Okanagan Nation Alliance and the Penticton Indian Band on a spring and headwater monitoring project focusing on the Shingle Creek watershed. As well as using Western science methods, the students were learning and experiencing the Silic water philosophy and culture. The students are keen to share some of the results and experiences. Please welcome the members of the Springs and Headwater Protection Project.
Hello everyone, thank you for being here today. We're pleased to present to you our project. We hope you enjoy.
Firstly, our team would like to humbly acknowledge that we are gathered today on the traditional, ancestral, and unceded territory of Selk Okanagan people. This ancestral territory covers nearly 70,000 square kilometers of British Columbia and the state of Washington, and has been cared for by the people of Selk since a time immemorial.
So we'd now like to formally introduce ourselves and our Capstone project.
Hello, I'm Priscilla Lau.
Hello, I'm Shiny Tamel.
I'm Stefan Pollack.
And my name is Tom Wilbrink. So for the last couple of 7 months or so, our team has been privileged to work with the Okanagan Nation Alliance in a one-of-its-kind collaboration with the Water Engineering Technology program here at the Okanagan College. So today we're going to start with an overview of our Capstone project and the importance of this work. And then we'll talk about our sampling methodology we created and highlight some of the water samples and testing results we did in the laboratory. Then we'll follow up with a short discussion and conclude with limitations and challenges we faced and come up with some recommendations for future students.
So what exactly did our Capstone project entail, and why is it important?
So our Capstone project was focused on springs and headwaters within the Shingle Creek watershed near Penticton. Specifically, the project entailed the creation of a water sampling methodology, useful maps of the watershed, and some initial water quality tests using our methodology created. Working with the Silk has added a level of significance to this project, which we hope that we've risen to meet.
So yeah, for the Silk, water is not just a commodity or a resource. It is the source of all possible existence, from which all forms come and to which they will end up. Water is a living being, and it requires reverence and respect. It provides for all the creatures on the earth, the Temich. And we as humans have a responsibility to care for it in return.
Springs are sacred places where water surfaces from the underground and are places of great responsibility for the Sikh. They are recognized as living relatives that also provide for the Tamich.
So the stewardship of water is a defining feature of their self-governance of Silk people. The philosophy is exemplified in the Silk Water Declaration. So throughout our presentation, we will be sharing some of this declaration with you, and we hope you reflect on the language within. Part of this philosophy is indigenous-led initiatives like Guardian programs, which seek to empower community members to become stewards of their land, and this was another aspect of our project. We were privileged to be able to engage in, and we will cover more about the Guardian program later in this presentation.
So with all these values in mind, the Nation Alliance sought out a group of students from the WET program to begin a process of collaboration, which we hope continues after our time at the college. This process began just about a year ago now, when our supervisor from OC, Aaron Radomski, and the coordinator from the Nation Alliance, the one and only Rich Busanik, started exchanging ideas about what a capstone project might look like. They knew that this would require a special group of students who were up to the task. After some initial brainstorming, this project was proposed to us back in April of this year, although it took a different form at the time. In July, Tessa Trebasket, a member of ONA, and Rich sought input from the Water Working Group about what they felt was most important for the community. From this meeting, they landed on the restoration and protection of springs and headwaters, and Penticton Indian Band volunteered to be the pilots for this project. This project has been a long time in the making, even before we knew that we'd be involved with it. We've been honored to have been able to work on it, and we hope that this is just the beginning. As Rich would say, we are weaving a basket together, which takes time.
Water is the lifeblood of our land and our animals, and we as Syilx people. First, we'll briefly share the methodology we created.
The document covers consideration of safety, sample locations, and handling, testings as well. Included within are sections about coliform testing, meadow and ion analysis, and multimeter data gathering. Templates for field data collection are also included inside as well.
In addition to what Priscilla said, there's a comprehensive section devoted to cultural data collection. A questionnaire had been modeled after similar project in New Zealand and South Africa. And we hope these templates provide value to community members and guardians as ways to document and preserve cultural knowledge about their land. Also included are some maps of the Shingle Creek watershed, which provide some baseline information about water features and human-made obstructions in the watershed.
Any use of water should be an act of reference and a commitment to our responsibilities.
So with this methodology that we created, our team engaged in a field trip with guardians from the Penticton Indian Band to collect water samples and learn from their knowledge. There was a little bit of preparation beforehand, as exemplified by Tom there.
At the direction of the guardians, we visited 6 sites, 5 of which were in the Shingle Creek watershed, and these sites represented a wide range of hydrogeologic features. Not all of them are springs.
And the intent of this field trip was threefold. Number 1 was to put our methodology into practice in the real world. Number 2 was to characterize a large portion of the Shingle Creek watershed. And number 3, most importantly, was to spend time on the land with the guardians from PIB, learning from their knowledge and experience.
Yeah, and at each site we measured standard water quality parameters using a handheld multimeter probe, and we collected water samples for testing in the lab.
We first started at the outlet of the watershed, where Shingle Creek empties into Okonon River at Penticton. Here we had a chance meeting with Kim Montgomery, who is the mental health lead for the Nation Alliance, who led us into a traditional tobacco song. It was a beautiful start to our day, and we thank her for that.
And we then moved a few hundred meters upstream, taking more samples directly from Shingle Creek. And this site was just upstream of the fish hatchery, and Shingle Creek is a major source of water for this aquifer, and that sustained the important work performed there.
The third site that we visited was a spring emerging directly from the side of mountainous rock formation, which is used heavily by members of the PIB community and members of the general public as well.
Yeah, and site number 4 was a stagnant pool of water on the PRB land that was there year-round. And here we enjoyed a delicious homemade lunch, and were gifted feathers from Dean, one of our guardians, which was a great honor, and he was willing to share the symbology with feathers with us as well. We also exchanged gifts with baked goods and some delicious honey from Aaron, our supervisor.
The fifth site visited was a shallow wetland adjacent to Shingle Creek, which a beaver has made its domain, which is in the middle image.
And finally, we ended the day sampling from a spring above Trout Creek. This spring is also used heavily by band members and the general public. Our sacred water teaches us that we have great strength to transform the highest mountain while being gentle, soft, and flexible.
And now we'll briefly share the test results performed on the water samples. So our team tested the samples for coliforms using IDEX tests. We checked for major anions present using ion chromatography. And we checked for metals like calcium and magnesium using flame spectrometry.
For the E. coli enumerations, samples were diluted and treated with food for any microbes present. And then the trays were incubated for 18 hours. Then IDEX software and UV fluorescence were used to determine the levels of total and fecal coliforms. In general, all of the fecal coliform pond and open river sections showed moderate amounts of total and fecal coliforms, which is expected, with the stagnant water at Site 4 being beyond the range of the IDEX tests, even with a 95% dilution of the samples.
So the ion we tested for were nitrate, nitrite, phosphate, sulfate, and chloride. This process involved the creation of many standards and very long method development period to ensure our data was sufficient. We were pleased to find that our chromatography data showed very low concentrations with compared to the Canadian drinking water guidelines.
The metals that we tested for were calcium and magnesium, two species which are very important for the biological functions of many aquatic organisms. This analysis involved a series of standard solutions and the acidification and digestion of our water samples. This process could have been expanded to test for other metals potentially in the water, like lead or mercury, though this didn't happen due to time and safety constraints. Our data showed moderate levels of calcium and magnesium at each site, with calcium being more abundant than the magnesium. We also checked this data with some third-party data from the City of Penticton's water report from last year, and we were pleased to find that our sites were very close in agreement with that data as well.
So our relationship with water is not taken lightly. We are responsible to ensure that our relation can continue to maintain the health and resiliency of our land and animals.
To wrap up the document and data section, we'd like to share some additional deliverables made for the Nation Alliance.
The Guardian program was a major aspect of this project. The methodology document created is intended to be used by Guardians to enhance their stewardship efforts. Part of being Guardian is engaging with members of the public. And so ONA requested that materials be created so that the Guardians can more quickly and easily engage in public outreach and education.
Yeah, and to this end, we created a brochure, and you can see a template there, with the information about the Silk Water philosophy, the Guardian program, and also more information about water stewardship. Parts of the document were written by Tessa Tabasket from the ONA Water Working Group, and we hope that this brochure provides information for the public about topics that they might not be aware of yet.
Additionally, a comprehensive bibliography was created, documenting sources that was used for the project. This document is intended to be used for any future Capstone groups to have a record of what was useful for our Capstone project and to the Nation Alliance.
Water bonds us to our ancestry, our descendants, and our land.
We'd like to transition now into talking about one of the most important aspects of our project, which was the engagement with the Silk community. We will briefly talk about some of the experiences we shared and some lessons we learned.
So something we haven't explicitly mentioned to this point, but you may have been able to guess, is that none of the members of this team are originally from Canada. And furthermore, none of us have had any prior experience working with First Nations like the Syilx. Because of this, it was incredibly important for us to put our best foot forward and engage with the community in a positive way.
Our team has been so grateful to have been welcomed by the members of the Nation Alliance, to have learned from their wisdom and share experiences with them. We learned about the 4 food chiefs during our second meeting with ONA from Tessa and Caroline. After that, we each shared which food chief we feel most connected to based on their different characteristics.
And after our initial meeting with ONA, we were invited to attend the Salmon Festival in OK Falls in September. Our team went along with our supervisor, Erin, and her lovely mother, and we had a really unique experience on that day. The community warmly welcomed us at lunch, and we were given the opportunity to take a ceremonial bite from a salmon that had been cooked. Each of us took a bite from the same fish, which felt like an honor and a powerful cultural moment. One of the most memorable part of the day was witnessing a special tradition. After the salmon was shared, the community carefully collected all the bones. With prayers and beautiful singing, they returned the bones to the creek. This practice made the respect shown toward the salmon, gave us a much deep appreciation of this hill culture. It was a unique experience for all of us.
And about 2 months ago now, we visited the fish hatchery, the Syilx fish hatchery in Penticton. And important work is taking place there, and water from the aquifers there is being used that is being fed by Shingle Creek. So it was very interesting to see how our Capstone project kind of connected with other parts of Syilx self-governance. And something I found especially powerful was when we had a talk with one of the band members, and he shared that he was feeling very honored to be working with the salmon and seeing them grow up and return every time. And he stressed that he felt a big responsibility, since the salmon not only improved healthy ecosystems, but also provided food for the community and for his own family. And plus it would provide a connection to the land as well.
During our tour, we learned many fascinating aspects of the hatchery operations. I was especially amazed of how the fish are marked with water temperature in their ear bones for identification. Seeing the level of effort, care, and technical precision really stood out to me. Those goes all into restoring the salmon population.
In the same day of our fish hatchery tour, our team engaged in a community roundtable on PIB land, where there were multiple elders and guardians and water operators from the community present. We shared some of our test results, and we listened to the voices of the community members, all of them incredibly passionate. This was an important meeting for our team, and we were grateful for the feedback given. We were especially delighted to hear from Rich that this roundtable sparked action for some of those present. Dean, who is the guardian who chaperoned us on our field trip, he began posting about spring protection measures on the local Facebook pages. Delaney Hall, who is a Tamik technician, so a wildlife technician, began inventorying springs and identified, we've been told, about 150 around Penticton, which is incredibly impressive. And finally, Rhonda McLean, who's also a PIB member and sister to Dean, began engaging with a local rancher who had expressed interest in working with the Nation Alliance on spring stewardship by sharing data about springs on his property and sharing ideas about how best to move forward.
So our hope is that this project is just the beginning of the collaboration between ONA and the Okanagan College. As a word of advice to future cohorts, we would like to say that the community aspect should not be overlooked, because You cannot build something great without a good foundation.
Water is our most sacred medicine. Water nourishes, replenishes, cleanses, and heals. It teaches us anything is possible. Now, while water may be limitless, unfortunately this project was not. So with that in mind, we're going to share some of the limitations and challenges of this project, as well as some recommendations for future projects. A major caveat of this project is that we only performed one-time testing at the sampling sites. As mentioned before, this is especially important for coliform testing, as our tests can't be used to declare that a certain spring is or isn't safe to drink from. That would require continual monitoring on a regular basis, with procedures in place to alert users to potential contamination. Furthermore, regular testing would allow a historical catalog of water quality to be cultivated, so that trends in the watershed can be identified and remedied if possible.
Another limitation of the project is the limited scope of testing within the Shingle Creek watershed. Ideally, we would have liked to test more sections of the Shingle Creek, springs, and even higher up in the watershed to create a better picture of the health of this important waterway. This could involve field reconnaissance to identify more springs in the area and would empower guardians to monitor these sacred places.
Finally, our short time working on this capstone project meant that we are not able to engage in other crucial work related to the stewardship of springs, a task involving infrastructure to restrict access, or further public outreach. To remedy this, we have a short list of recommendations to the Okanagan Nation Alliance. Stefan?
Yeah, so number one would be to consider restricting access to the springs at the 3rd and the 6th site that we visited, allowing only band members to use them, as is their traditional right.
And number two would be to consider recurring testing at the aforementioned springs, and to reduce the likelihood of coliform-induced illnesses for users of those springs.
Third, consider testings for heavy metals, particularly mercury, as it can bioaccumulate in salmons and pose health risks to consumers.
And finally, consider environmental or eDNA analysis of selected sites within the Shingle Creek watershed to monitor for potential invasive species and to monitor for the decline or increase in traditional populations of organisms.
So we'd now like to take some time to thank the wonderful people who have helped us on this journey. We would be here until the cows come home if we listed every single person who was involved in this project. So just know that there are tons of people who helped us that we're not mentioning specifically by name.
From the Sikh Okanagan Nation Alliance, we'd like to thank Rich, who is here today at the back seat, Tessa, Eva, Kim, and everyone else involved.
Yeah, and from the Penticton Indian Band, we would like to thank Marissa, Caroline, Dean, and Jordan, and all the elders that were present, and everybody else that was present at the community roundtable meeting.
Yeah, and from the college, first I would like to thank my wonderful team members and our supervisor Erin and amazing lab techs and all of our professors who helped us.
And finally, we'd like to thank all of you for your time and attention today. So in many ways, this capstone project was very unique, and we hope that that's been expressed through our presentation today. We've been very grateful for this unique opportunity, and we hope that our work for the Nation Alliance is just the first in many collaborations. So from the bottom of our hearts, thank you to everybody. And if you have any questions, please, we would love to take those. I think I see our lab tech with a question. Yes, this last image here is indeed Spotted Lake. We didn't mention it in our presentation, but it does hold quite a bit of spiritual significance to the Syilx Nation. It's considered to be the mother lake in the region, and it's incredibly unique. If you couldn't tell from the picture, it has tons of unique niches for bacteria and others that grow there, giving it that amazing color. No, we did not test spotted lake. That's correct. Yes.
That was amazing.
Thank you.
Aaron, Lim, Stefan, Priscilla, Shiny, Tom. Hands up. Lim to the college and taking courage in this. This was, we talked about different things, Aaron, and the community and various folks that were mentioned on the shoulder of giants. Seriously. I've been doing this 30 years, and to watch how the group moved and we're moved within the community, I can't express the appreciation. And for those SEALCS members that are watching today or going to follow up with recordings, this was an amazing project. Why is this an expression of breathing in things before you and things that are behind you when you greet community members, which is something that was done on a regular basis, ceremonies, prayers, offerings, and the like. Aaron was amazing because there was a lot of planning that went up to this moment. This wasn't just a finger snap, let's get together. There was a lot of time and cooking behind the scene. And what was amazing was when she said, I have a very special group. I think we can do this. So this is going to flow where it's going to take us, but you provided a lot of honor. Lim.
Thank you, Reg.
Thank you.
All right, and for our final presentation, Group 5, they did a microscopic assessment of filamentous bacteria and flock properties to support biofoaming mitigation in the City of Kelowna wastewater treatment plant. All right, so the group members are Christopher Batan. Thank you, sorry. I know you by your first name. Retinder Paul Chad Jackson. This project focuses on identifying filamentous bacteria and characterizing the properties of flock associated with biofoaming and bulking in the City of Kelowna wastewater treatment plant. Samples collected from aerobic bioreactors, RAS, and the secondary clarifier were examined using phase contrast microscopy and established morphological classification methods. Flock structure, size, and hydrophobicity were also evaluated alongside key operational parameters to understand conditions that favor filamentous growth. By determining the filament types most commonly present in the plant and relating them to observed flock characteristics and operating conditions, this project provides the City of Kelowna with insights into likely biofoaming contributors. It supports the development of targeted mitigation strategies. And I'll pass it on to you guys.
All right. It's done. You summarized it.
You already did our project for us. Hello, everyone. My name is Chad. Oh. Hello, everyone. My name is Chad. This is Chris, this is Ratinder, and we will presenting our capstone project of microscopic assessment of filamentous bacteria and flock properties to support biofilming mitigation. Our industry partner is the City of Kelowna, and our research supervisor is Aaron Redomsky. The importance of wastewater is to safeguard public health, protect the environment, and provide a sustainable water resource. For foaming and bulking, foaming involves an overabundance of activated sludge, causing the flock to become less dense in water. When it comes to sludge bulking, it creates an interference with settling characteristics, causing a loss of treatment efficiency. Our project objectives were as the following: to characterize filamentous bacteria across key treatment areas, quantify flock size, structure, hydrophobicity using image analysis, as well as compare sludge properties in the foam versus non-foam areas, and analyze relationships between filamentous flock traits and operational data. Allow me to give the floor to Ratinder. He will be talking about the methodology of our capstone project.
So image-based flock area quantification and batch analysis. So for this, flock size was calculated using a free and open source software called ImageJ. Bright field micrographs of activated sludge were collected under same magnification and illumination so the images could be compared fairly. To minimize operator bias and keep the work reproducible and standardized, automated workflow was adapted for all the images. Before measuring flocks, spatial calibration was performed using the scale reference in the micrographs. A linear measurement from the scale bar was used to set the pixel to micrometer conversion factor, and this calibration was applied globally to all the images. The images after were converted to an 8-bit grayscale and segmented using automated global thresholding method to separate flock and other from the background. After automated global thresholding method, after thresholding, images were turned into binary mask and internal voids within the segmented flocks were filled, so each flock was treated as a single continuous object. To handle the data set efficiently, we ran the full workflows using batch processing, applying the same pre-processing parameters, thresholding method, and particle analysis criteria to every single image. This ensured consistent flock detection, objective area quantification, and reproducible results across all the samples. So this is the ImageJ software, and as you can see, it outlines the flock and it captures the area. Talking about the statistical and multivariate analysis, after the image measurements, we evaluated flock structure properties, hydrophobicity, filament occurrence, and operational parameters using descriptor, correlation, and multivariate analysis. Temporal changes in the flock development and hydrophobicity were assessed in aviation basin, RAS, secondary clarifier, and the foam samples, with microscopy measurements summarized by sampling events. Relationship between mean flock size and mean hydrophobicity were examined using Pearson correlation and simple linear regression to quantify association between flock expansion and surface physiochemical properties. Evaluation of MLSS and SVI using Pearson correlation and linear regression was done to assess how biomass concentration influenced settleability. Filament-to-filament co-occurrence using Pearson correlations calculated from presence-absence data to identify coordinated or independent distribution patterns. To identify filament types linked with elevated hydrophobicity, finally, we explored multivariate relationships among flock size, hydrophobicity, MLSS, and SVI using PCA on standardized variables, which help differentiate characteristics associated with foam, aviation RAS, and clarified samples. Now I would like to pass on to Chris, and he will be talking about resultant analysis.
Thank you, Ritender. So after 8 weeks of sampling, we process our data. And as you can see in the table, we have the sample, the flock size, the hydrophobicity, and the filamentous bacteria composition on each sample. I am only showing you the September 26 sampling because from until November 14, that's the last sample, the data, the parameters are all still the same. What varies are just the numbers of the flock size, hydrophobicity, and the microbial composition. So we also took all the core parameters from the plant. And again, I'm only showing the September 26 data because this is pretty much the same until November 14. What changes there are the numbers from the BN2, and the X there stands that the plant don't get that data. So it is noteworthy to mention that the core parameters from the plant are within the ideal range for normal operations. And for that, we are left with the microscopic process data. We have to analyze the trends and correlations. Overall, we have this BN2 samples from the BN2 tank, and we can see the flock size, the hydrophobicity index, and the microbial composition. And then we move over to B3F tank, and we can see that the flock size and the hydrophobicity index increases while the microbial composition remains the same. And for the secondary clarifier, our flock size, hydrophobicity index, it's reduced, and the microbial composition is also reduced, or the diversity. And for the B5B6 tank, we can see that the flock size, hydrophobicity index, it's like bloating up, while the microbial diversity, it's like low. And for the RAS flock size and the hydrophobicity index is above the value for the secondary clarifier, and you can see the microbial composition there. So overall, I'd like to mention that the flock size, the hydrophobicity index from this data changes. Also microbial composition. So let's take a look at the relationship of the hydrophobicity and the flock size in this graph. It says that this graph shows that if you have a larger flux, it tends to be associated with higher hydrophobicity, exemplified by the BF3 samples. However, this relationship is not strictly proportional across all tanks. As you can see, the RAS and the clarifier, secondary clarifier samples is at the bottom, which suggests that that hydrophobicity is an important but not exclusive driver of flock enlargement. And further suggests that microbial community composition and other processes may contribute to large flock enlargement. So when we aggregate, when the data are aggregated by process unit and plotted directly as mean flux size versus mean hydrophobicity, a strong positive linear relationship emerges, as you can see here. That the regression indicates that 90% of the variability is hydrophobicity is explained by flux size alone. That the flux size increases from the clarifier to the B3F sample as well as its hydrophobicity. Therefore, the large flux with high hydrophobicity are characteristics of foam-associated biomass. The take-home message for this is that large flux consistently exhibit higher surface hydrophobicity, supporting the hypothesis that microbial composition and EPS characteristics drive both flux enlargement and foam potential. Now let's go back to the core parameters obtained from the plant. As I mentioned earlier, that the MLSS and SVI are within the ideal range for normal operation. And it has been suggested that higher biomass concentration may contribute to denser flux through increased collision frequency and bioflocculation. We are trying to test whether the bulk biomass concentration explains sludge structure and settability. However, in this graph, it shows that there is a weak link within versus the MLSS and SBI, which suggests that biomass concentration is not the primary driver of flux openness or improved settability. In other words, microbial composition, EPS chemistry, and filament architecture dominate over bulk solid concentration. When we look into the correlation analysis between the flux hydrophobicity and filament presence, we take note that the filament-specific association with flux openness with type 00441 here, exhibiting the strongest positive correlation, followed by the microtrix, then type 021N and type 0675, and in contrast, type 1851 showed negligible correlation. In some studies, type 0041 was reported to bridge flux structure, increase surface roughness and porosity, and promote interflux attachment rather than compaction. In other words, when you have type 0041, this is like an engineer of the filamentous bacteria because it invites open flux structure. So therefore, in this graph, the filament abundance and hydrophobicity or structural looseness are correlated. In other words, flux are built, not accumulated. They are built by specific microbes, not by MLSS. We examined if there is a filament-to-filament co-occurrence patterns based on person correlation analysis. And this graph shows that filament-to-filament correlation analysis revealed structure patterns of co-occurrence and exclusion among dominant filamentous bacteria. A strong positive association was observed between type 1851 and microtrix, suggesting cooperative or co-selected growth, while multiple negative correlations here, as can be shown in this partnership, indicated competitive interactions among other filament pairs. This structured microbial relationship support the concept that activated sludge flux are biologically assembled communities with specific microbial interactions governing flux architecture rather than random aggregation of biomass. Therefore, certain filaments, they do not act alone. They form structural alliance that define the flux phenotype. We want to know if there is a multivariate signatures of all sample sludge. And in this slide, principal component analysis revealed that a single dominant axis that separated sludge samples by process location and flux phenotype form associated B3 right there. And as you can see, the RAS and the secondary clarifier form a group here. These foam-associated B3F and high variability aeration basin samples were clearly distinguished from compact clarifier and RAS sludge, indicating that flux size, hydrophobicity, and microbial composition co-varied as an integrated structural response. These support the concept that activated sludge flux are biologically assembled communities shaped by microbial selection rather than bulk biomass concentration. And for this slide, here we present here, these are the dominant filamentous bacteria that we have seen at the plant, and besides to it, the dominant growth conditions and operational strategies to minimize biofoaming. Withdrawn from multiple established publications, the table is intended to resonate with operators by framing the filament control not as a laboratory abstraction, but as a practical process-based tool to guide informed adjustment aimed at minimizing biofoaming and filamentous proliferation. With that, we conclude that increasing biomass did not guarantee improved settlability, confirming that MLSS is not a decisive structural driver for flux formation. Flux size and surface hydrophobicity emerge as tightly coupled traits indicating that physical structure governs flux behavior. And only select filamentous organisms are altered flux architecture, highlighting the importance of microbial identity over abundance. And lastly, occurrence and exclusion among filaments shape flux structure, showing that flux are built through microbial interactions. And to make this study more rigid, we would like to recommend the following: address data completeness, design studies to capture seasons, not just snapshots, because what we did is just like a snapshots. Quality filaments rather than simply noting their absence and presence, because that's what we did. We just note the presence and absence, not by their qualitative trait. Increase replication and statistical robustness, strengthen filament-to-filament occurrence analysis, and standardize and clearly report methods. We would like to thank the people here to make this study possible: Erin, Chris, Mike, Kevin, Katie, Nicole, Chelsea, Amanda, and all the entire staff of the wastewater plant, and also our sincere appreciation to our wet professors, Alison, Erin, Owen, Dave, Frank, Emily, Sydney, Maria, and Felix. It's not there. Well, these are our references, and thank you very much. Everybody's hungry, so yeah, it's okay not to ask questions.
Hi. So if you could have done one more thing with your project, what would you have liked to have added to it?
Thank you for that question, Erin. I'm not expecting you to ask a question. Okay. Well, the filament-to-filament bridges is very important. As what I've said, the architecture of open flock depends upon the filament-filament bridging and openness of the flock. So we have already dissected the hydrophobicity and able to come up with methods how to measure it accurately by the image J analysis, but we need the filament-to-filament bridges and count the abundance with the filament structure. Because if you have a flock, it is surrounded by those filamentous bacteria, and we need to know what are the types and how are they bridging. So if gonna add something to this study, it's gonna be taking the filament-to-filament bridging. And that's possible with microscopy, if you can obtain one. Erin is like trying to buy one, so maybe next year they will have this.
All right, thank you guys. And that concludes the presentations for the capstone. Again, a big round of applause for everybody. And David Teasdale is here. Good. Okay. Every year we award a presentation to the graduate student of the year. And I'll hand it off to David to give that award.
All right, can you do me a favor and grab it down there? I will. All right. Thank you, Frank. I've got some hurt ribs, so Frank's helping me out here by bending down. All right, so we have their award presentation to the Graduate Student of the Year. So the Graduate Student of the Year represents the highest standard of achievement, combining academic experience, technical mastery, and personal integrity. This honor celebrates a student who demonstrates critical thinking, strong communication, and collaborative spirit, while embodying leadership, adaptability, and cultural awareness. With a proven work ethic, curiosity for lifetime learning, and reliability in every endeavor, the recipient exemplifies the qualities that define an outstanding graduate prepared to make a lasting impact. For 2025, I would like to invite Stefan Pollack up to the stage. Congratulations, Stefan. Now you got to stand here while I read all these nice words about you to tell you who Stefan is. All right, we put together a few words that exemplify who Stefan is and some of the things that represent Stefan's qualities. Here you go. I'm sorry, I know it's embarrassing, but you got to sit there and listen. Okay, Stefan is widely recognized as an academic standout, consistently demonstrating technical excellence along with strong communication and teamwork skills. His classmates admire not only his brilliance and reliability, but his kindness, positivity, and willingness to help others. Stefan shows clarity and confidence that inspire those around him. Beyond academics, Stefan's proactive nature and modest personality make him a valued peer. His cheerful demeanor, hard work, and readiness to lend support embody the qualities of both an exceptional student and a remarkable classmate. With this award, we celebrate the achievements and acknowledge that while he may shy away from attention, the recognition is truly well-deserved. He leaves behind a legacy of excellence, generosity, and friendship. Congratulations, Stefan. So ironically, Stefan was actually due up here next, so we're going to hand it over to him, kind of give his little victory speech, and then he can take it away from there. Try that one.
This one works?
Good.
This one does work.
We'll do a duel? No.
I'd love to, Dave. Whatever your favorite song is, that'd be awesome. Not so much a victory speech, but Angelica Kalub, she asked me to give some remarks for the students in a little bit of an address. So I'd like to start by saying congratulations to all of you. It's been roughly 830 days since we started this program in September of 2023, and it's been a true joy to have shared it with all of you. For some of us, this is the first diploma that we're receiving. For others, this was not your first rodeo, and others still took on this responsibility after a long hiatus from education, working tirelessly to support your families at the same time. So I commend all of you for reaching this point. You should all be incredibly proud of yourself. I'd now like to speak for my fellow students and express our gratitude to our amazing professors who have been alongside us every step of the way. And you'll see soon that this ties into something that Angelica has prepared for them. So we've got some nicknames for the professors. Perhaps they have heard these by now, but maybe not. So the amazing Allison O'Neill, also known as Bernoulli, Aaron Radomski, the Cell Sparkle, Mr. Dave Teasdale, the Bubble Rocker, Owen Lloyd, who is the Wrench Warrior, Frank Carey, also known as Marley, Sydney Atomic Star Acton, who, for anybody unaware, she actually recently gave birth to her first child, which was amazing, and we're all so happy for her. So wherever you are, Sydney, we love you. Emily Lee, the Equation Enforcer, I think I saw her in here. Yes, there she is. And as well as Janice McQuilkin, Maria Semperoli, who covered for some of our chemistry lectures towards the end of the semester, and Elizabeth Strom. You have all changed our lives for the better, and we are indebted to your service. If there's some aspect of society that's often unduly reviled, we could probably all agree that it's education, unfortunately. And I know that I've been guilty of this at times, wondering why I would spend thousands of dollars and, drive 2 hours every day to get a piece of paper at the end of all of it. But that's a failure of my mind to realize the true nature and importance of education. It quite literally brings you out of the darkness to effect positive changes in the world and to change lives of others for the better. This program is exemplary of that idea. We've arrived in a world that has many issues which will affect the world of water, but we're now able to enter that world with the skills to improve it. And all that is possible because of you, our incredible teachers. So with all that being said, I'd like to call the faculty actually up to the stage. We have some gifts for all of you, after which Angelica has prepared a video, which I have not seen at all, so I'm incredibly excited for that. So if I could get the professors up, as well as our lab tech, Isabel, there's something for you as well. So make your way down to the stage, and we've got some things for you. Am I like presenting it to them, or?
I can do it.
You got it? Do you want me to hand them out? Do you want me to hand them out? Okay, great.
Not sure I was.
Oh, yeah. Oh, you're part. Oh, yes. Oh, yes. Absolutely. You're part of this too, Owen.
In my own world at the best of times.
Oh, yeah. All right. So any order, Angelica? I guess we'll just go down the line. So Mr. Dave Teasdale, the Bubble Rocker. Something for you. Yeah, you might as well. So I wish we had a way to show these on screen, but these are amazing, I guess you could say, edits of the professors and instructors in some pretty awesome clothing with their nicknames on them. Up next, Owen Lloyd, the Wrench Warrior. Emily Lee, the Equation Enforcer. Up next would be Frank Carey, also known as Marley. Isabel Keurig? Yes, there we go. Up next would be Allison O'Neill Bernoulli. Up next, Aaron Radomski, somebody who I have had so many classes with this semester, but they've all been amazing. Miss Cell Sparkle, I believe there's a gastrotricha on your image, so we hope you enjoy. And of course, Matt, one of our lab techs. And a group collage, which might be hung in C140, hopefully. Oh yeah, great. Thank you again. We love you all very much. And not to repeat myself, but we are truly indebted to you. So thanks for everything.
Second year students, graduating students, do you want to sit closer together, maybe in the middle? Yes, please. so we can enjoy this moment.
Here in Kelowna by the lake so blue, we're learning water science, me and you. Pipes and pumps and chemistry. Back in college, we're coming through. Water tech, we keep it clean, protecting rivers, lakes, and streams. From the map to biology, we're the future of water. Sustainability is chemistry mixed keeps the water near. Owens O&M keeps systems strong to guide us along. Do you trust Fred? No. Do you trust Fred? No. But he'll still teach us everything we need to know. We've got two paths that make us complete. Treatment or monitoring, both can't be beat. The proofers clean water, they handle the flow. The micros watch nature where the water flows. Water tech, we keep it clean, protecting rivers, lakes, and streams. From Kelowna to the world, we'll be the guardians of water. Sustainability. Dave teaches treatment, the filters on show. Aaron's biology shows how microbes grow. Emily's math makes it all make sense. Building skills that are strong any man. Water tech, we keep it clean, protecting rivers, lakes, and streams. From Kelowna to the world, we'll be water technicians. That's you and me. So raise a glass of clean H2O. We're the techs the world should know. In BC's heart, we proudly say, water technicians will lead the way. Are you ready? Are you ready? Are you ready? Get wet. Are you ready? Get wet.
I watched a lot of music videos in the 1980s. Oh my gosh, don't actually play it.
There you go.
Oh, hang on. Pretend you have an opinion about what's happening.
Exactly.
On the board. Like you're grading biology 175.
Yeah. Oh man, that'll put it.
I have no idea what any of these buttons and knobs do.
Do you know?
Not that.
Yeah.
give that a
Pretend
little
you have opinions about where those knobs go. Yeah, you should look at the
That
camera
honestly looks like the inside of, that's so perfect.
That's
Who makes this?
That was correct. That was
No. These are all motorized painters anyway, so they could.
Oh.
Look at that. Yeah, see? There you go. Be good.
Aaron. Freeze.
Oh, it's not done yet.
We walked in not knowing where this road would lead. Through labs and long nights we planted the seed. Chemistry struggles, equations in time. We carried each other, we learned how to climb. Cindy with chemistry, reactions in hand. Emily's equations, we try to understand. Dave with his treatment, the filters in view. Air in small worlds that somehow felt true. From classrooms to fieldwork, the lessons we keep, the laughter, the stress, the memories deep. Now the time's come, but we'll never forget. We're forever the class who learned to get wet. Batch 2025, our journey's complete. Through water and waste, where our passions meet. The poopers and micros, our stories align. One final goodbye, but our spirits still shine. Allison showed us how the water is shared. Owen taught systems with patience and care. Frank gave us laws to guide what is right. We carry his lessons through the night. The tests and the deadlines, the hours we gave, the friendships we built, the memories we saved. No matter the distance, no matter the end, these moments will live in the thoughts of our friends. Batch 2025, our journey's complete. Through water and waste, there our passions meet. The pookers and micros, our stories align. One final goodbye, but our spirits still shine. So here's to the nights, the laughs and the pain, the friends that we've made, the knowledge we gained. No matter the path, our hearts won't regret. We're forever the water techs who love to get. For all that you've done, and to every student together we've won. Batch 2025, we'll never forget this chapter of water where our hearts first met. We'll carry it, yeah. Forever remember we love to get.
Wow, that was quite remarkable, to say the least. Thank you, Angelica, for putting that together. I think that's the first time anybody here has seen it. Very well done. Okay, with that said, these are the closing remarks. I would like to start to say it's been an honor to stand in front of you students for the last 2.5 years. Normally I just get up in front of you and I talk. I actually don't read notes, but I thought I would actually prepare something here today. So I'm actually going to read this because I put some time into this, and I thought what better way to finish off my time in front of you with the closing remarks here. And I call this one The Road Ahead. So something's just not quite right here. I got to try to make it feel more like the classroom. So we got to fix the overview screen first. Let me see if I can get that fixed right now. Don't have my reading glasses on. There we go. So let's get this one fixed. To give you more of an experience like you would encounter in class. So we'll start off with a bit of background. And one final toast to the graduating group before I start. I've tried. Okay. Throw a marker. All right. This is called The Road Ahead. So I want to say before we wrap up today, I want to take you back to the 80s with me. Not that you haven't heard that before. Okay, so picture this. You're behind the wheel of a 1979 Trans Am. T-tops off, engines rumbling. You have some heavy metal music playing, maybe some Rat or Van Halen. The music turned up to 10, of course. You glance in the rearview mirror, and there it is, Okanagan College. Now, that chapter, while it might be behind you, it's not gone though. So the rearview mirror isn't for forgetting, it's for remembering where you've been, what you've learned, and how far you've already come. Looking back, late nights, deadlines, group projects that somehow came together at the last minute, those memories will last forever, even as you drive forward. So make no mistake, the road ahead is wide open. But I'll be honest with you, every step, every drive is going to have its bumps. You're going to hit potholes you didn't see. You're going to see detours along the way, some that are clearly marked, others that feel restrictive, like a speed limit sign. And yes, there may be moments when the check engine light comes on and you think, well, that can't be good. Well, that's life. But here's the thing. You don't pull over because the road gets tough. You adjust. You learn to handle the curves. And sometimes those detours that take you to places you've never planned to go, but you're really glad you found. You've all proven that you can do this. The Capstone, it's your proof of concept. It shows that you can think critically, collaborate, problem solve, and keep things going even when the ride gets a little shaky. And just like the Trans Am, something we can all relate to. You don't need all the answers before you start the engine, as long as you got the courage to put it in drive. So as you head out on your own highways, careers, maybe further studies, adventures we can't even imagine yet, remember this. Check your mirrors once in a while. Be proud of where you've been. Keep your eyes forward. The road ahead is yours. And to finish, when you hit a bump, maybe ease off the gas just a little bit, but never turn around. Congratulations, Water Engineering Technology class of 2025. Well done. Now, one thing left to do, get out there and enjoy the ride. Thank you. If we can get everybody up on stage for just one last group photo, kind of a last memento, and that'll conclude our presentation today.